fundamental theorem of arithmetic. Okay. Now, in root it is 2. So we have to take 2m in the place of p. Okay. If root it is 3, we can take here 3m. If root it is 5, 5m. Okay. So here root it is 2. In the place of p, we can take 2m. Okay. From equation number 1. From equation 1. Okay. From equation 1, we can say, okay, p square equal to 2q square. In the p, we can put 2m. 2m whole square equal to 2q square. 4m square equal to 2q square. Now, 2 divide 4 become 2. So, q square is equal to 2m square. So, here another statement is coming. In this statement also we get idea. 2 divides q square, 2 divide q. 2 divides q square, 2 divide q. So, this is statement 3 and that is statement 2. Here we know that 2 divides p. Here we know that 2 divides q. So, in any rational number, p and q are integer and they must be in the smallest form. Only one can be divided both in common. Other number cannot be permitted to divide in the case of rational. So, here you are looking 2 divide numerator also or 2 divide denominator also. And it from equation 2 and 3 we get no 2 divides p and q both. That means SCF of p and q is 2. So for being a rational number, SCF must be 1, not equal to 2. So p by q is not a rational number. Okay, because it is contradicted. It is contradicted. It is a contradicted. Okay, it is contradicted. Clear? So p by q is not a rational number. So p by q value is root 2. The root 2 is irrational number. Okay, students, you understand this is properly? And here I have taken the concept of rational. Okay, the 2 divides p square, that means 2 divides p. 2 divides q square, that means 2 divide q. The 2 is a divisor of p also and 2 is a divisor of q also. The numerator and denominator both is divided by 2. For being a rational number, p and q divide by only 1, not by any other number. So being a rational number, SCF of p and q should be 1, not 2. Okay, so p by q is not a rational number, so it is contradicted concept. The root 2 is a irrational. Here I have taken a rational. It is wrong because here 1 and not 1 not equal to 2 in the case of SCF of p and q. So root 2 is not a rational number. Root 2 is a irrational number. Clear? Now some more questions. Less number is there, not too much. Prove that 3 plus 2 root 5. Prove that 3 plus 2 root 5 is irrational. 3 plus 2 root 5 is irrational. Clear? So let we suppose 3 plus 2 root 5 is a rational. We take p by q in the place of this. P by q equal to 3 plus 2 root 5. And because it is a rational number, so we can equate with p by q. Here q not equal to 0. Okay. Now 3 we can send here, become minus. The same function we have to do both sides. Minus 3 I have done both sides. The p by q minus 3 equal to 2 root 5. Now we have to send 2. 2 is multiply. The here it will be divide. The multiplying both sides by 1 by 2. We get the p by q minus 3 into 1 by 2. 2 root 5 into 1 by 2. 2 cancel. Okay. Root 5. Look here, students. P by q is a rational number. 3 is a rational number. Rational minus rational, always rational. And this result is a rational. A rational multiplied by 1 by 2. 1 by 2 is also rational. The rational into rational always be a rational. Okay. But root 5 is a irrational. Okay. The rational minus rational always be rational. And rational multiplied by rational always be a rational. But root 5 is irrational because 5 is prime number and the square root of any prime number is irrational. So here in LHS we are looking rational and RHS we are looking irrational. So rational equal to irrational, it is contradicted concept. So we can say your p by q is not a rational number. So 3 plus 2 root 5 is not a. So 3 plus 2 root 5 is not a rational number. It is irrational number. Clear? Now 2 more pages are there. Okay, that's only. Explain why explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is our composite number. For composite number, the number a result should have more than two factor. That means result should be divisible by one number and more than one number, more than two number, and if one and itself and some more numbers. That is the concept. So you just go with the first examples, 7 into 11 into 13 plus 13. Now look, in this number 13 is written in the multiply form and after plus 13 is there. So here one term is there, second term is there, two terms are there. From both term we can take common 13 as a process of factorization. 13 take common. They are 7 into 11 and here nothing means one is hidden. 13 means 13 into 1 we can write. So when we take common 13 from the number, okay, the 7 into 11 a plus 1, 7 into 11 here and here 1 is remaining. The 7 into 11 is 77 plus 1, 78. The 13 into 17, 13 into 78. So now look here, 7 into 11 into 13 plus 13 we can write into 13 into 78 and we can write also multiply by 1. So look what is the result is coming. In this result, that result can be broken down into 13 into 78 into 1. So here we are looking three numbers. Okay, more number can be possible, but we are showing only three numbers. That means we have to follow the definition of composite number. So in the solution of this number, 1, 13 and 78 are factors. So they are three numbers. If a number has more than two factors, that is the composite number. So this number is a composite number. Similarly, another example we can also solve like this. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So 5 means 5 into 1 you suppose. Now 5 we can take common. After taking 5 common, 7, 6, 4, 3, 2, 1 here. And after plus 1 is there. Multiply all. 1008 coming plus 1, 1009 coming after addition. Now 1009 we into 1 we can write. So here 7 into 6 into 5 plus into 4 into 3 into 1, okay, plus 5. In the solution of this 5, 1, 1009, they are three different numbers. They are coming as a factors. Okay, the factor of result of this. Okay, so it has three factors. That means more than two factors. So it is a composite number. Now, clear? Now last theorem is there. Theorem 1.5. Let x be a rational number whose decimal expansion terminate. Then x can be expressed in the form of p by q. P and q are co-prime number and the prime factorization of q is either the form of 2n and 5n. And n and m are positive integers, non-negative integers. Okay, what is the meaning of this? Meaning of this is should be clear from this. Ki number is p by q. Look here, number is p by q. Okay, q is a denominator. If the prime factor of denominator is coming 2 and 5 form only, then it will be stop in decimal and it terminate in decimal. If we do the prime factor of denominator, if the prime factor of denominator will come in the form of 2 and 5 only as a prime number, then this answer will end in decimal. That means terminate in decimal. That is the concept of terminating in decimal. So x be the rational number whose decimal expansion terminate and x can be expressed, x means p by q form. P and q co-prime number. Co-prime number means no common anything. You know? And the prime factorization of q and a q prime factor should be come in the form of 2 to the power n, 5 to the power n. N and m are non-negative integer. That means positive integer. Just like 2 and 5, m and n are 1, 2, 3 like this. Okay. So we can say the prime factor of denominator, if it is coming in 2 and 5 form only, then P by Q will end in decimal. That is the concept of terminating in decimal. And if it is not coming 2, 5, है ना, 2 only coming, 5 only coming, then also it is a terminating a decimal. But other prime number will come as a factor of Q, just like 257, 253, or 2353, like this. Then P by Q is not end in decimal. Clear? Just go with the example. Last page is there. 3 by 8. When we do the prime factor of 8, 2Q. So only 2 is there. We can write, if you want to show the 2 and 5 both, so we can multiply, it is a Q form, na? So we can multiply 5 cube up and down. So 5 cube, 125 into 3, 375. I add 2 cube into 5 cube. That means 2 into 5 in bracket of cube as a whole. The 10 cube. 10 cube is 1000. 375 divided by 1000, 0.375. It is terminating in decimal. Just like go by the 7 by 80. 80 means 16 into 5. Yeah, 2 4 times. 5 1 times. 3 times more needed. The 3 times up and down. Here already in the product form is written. The 3 form here also, and one more form is there. And it just like we do 5 power 3, 5 power 3. Okay. So here 7 into 5 power 3, 5 power 3 into 5, 5 power 4 and 2 power 4. The 2 power 4 and 5 power 4. The 2 into 5, 10 power 4. The here 5 cube, 125 into 7, 875. By 10 power 4, yani 10,000. The 10,000 divide this 0.0875. And it will end in decimal. Clear? So why it is end in decimal? Because the denominator form of this number always 2 and 5 only. Here also 2 and 5 only. So it will end in decimal. If the decimal expansion of Q is non-terminating but repeating, that is rational. Just like 1 by 3, 0.333. Okay, 1 by 7, 0.142857 recurring. Okay, and 142857, 142857, 142857, like this it is repeating. Okay, decimal form is not going to end, but it's repeating, so it is also a rational. Okay, if the decimal form of Q is non-terminating, okay, non-terminating, okay, but non-repeating, it is called irrational. Non-terminating and non-repeating, so it is a irrational. Just like a root 2, 1.414, not end in decimal, not repeating decimal, so it is irrational. Okay, some other formulas is there. Suppose we have given fraction type of numbers, we have to find the SCF. Okay, so we have to find the SCF of P by Q and R by S. So how could we do? First, we have to find the SCF of numerator and LCM of denominator. What SCF of numerator is coming, you write up, and what LCM of denominator you will write down. Okay. Similarly, we have to find the LCM. Okay, P by Q and R by S. So LCM of numerator we write up, and SCF of denominator we write down. Okay, and this is two numbers, A into B. Two numbers are there. What is the product of both number? That is equal to SCF of both number, SCF of both number into LCM of both number. What is the SCF of both number and LCM of both number is coming? What is the SCF and LCM of both number is coming? If we take the product of this number, that product is equal to the direct multiplication of both number. So this is the last formula. Thanks.